Hi Calculus students, this is page 13 of your video packet. This is video 4-6 for Wednesday, December 7th. And I will give a little bit of homework with this because it's going to be very short. The homework's going to be page 11, numbers 1 and 2. So 2 homework problems. So what we're doing here is we are given the graph of the second derivative of a function h. So this is the graph of the second derivative. And then we're going to answer a bunch of questions about h and h prime while looking at the second derivative graph. And for this, you'll want to be using Susan's table. So if you flip over here, the page just, right before this, we wrote down Susan's table. We're going to be referring to this, and guys, the information in this table really does need to be automatic, okay? The things that appear in the same row are synonymous with each other. Okay, for example, for f to be concave up is the same as saying that f prime is increasing, is the same as saying as f double prime is positive. Now, flipping back over, because we are going to determine a bunch of stuff by looking at the graph of h double prime, all of our explanations will have to rely on h double prime, okay? And also, since we're relying on the graph of h double prime, you're going to want to begin, when you're trying to figure stuff out, you'll want to begin in this column here. Okay, knowing that f double prime is positive versus negative or has a sign change at a certain value, these are the things that we're going to be looking out for because they're going to imply the other stuff in the table. Okay, so given the graph of h double prime, answer the following, and we're going to explain everything. When is h of x concave up? Okay, when is h of x concave up? This is not the graph of h, this is the graph of h double prime. So you can't say, oh, it's always concave up. No, this is not the graph of h. This is h double prime. Well, looking at h double prime and knowing the information in this table, they want to know, and this is not really necessary, but let me do it. So we're dealing, our function's called h instead of f. So we want to know, when is h concave up? Well, h is going to be concave up when these other things happen. And since we're looking at the graph of h double prime, we're going to be looking for where h double prime is positive. Where h double prime is positive, the original function will be concave up. All right? So, and let's assume the graph continues in either direction. But, so I'm going to put dots there. Because that's where h double prime will change from positive to negative. So, concave up. All right, so concave up when h double prime is positive. So from negative infinity to negative 2 union, and then from 4 to infinity, and then I'll say because h double prime is greater than 0 on these intervals. Okay, now go ahead of me if you've got this. When is h of x concave down? Explain. Okay, so you've got to know Susan's table here. Concave down for the original function, we would get that if we knew that h double prime was negative, so below the x-axis. So the interval this time is from negative 2 to 4, and I'll say because h double prime is less than 0 on this interval. Okay, it's important, guys, that your explanation is the explanation you're using is referencing the information that you're given. So we're given h double prime, so we're using h double prime in our explanation. We wouldn't want to say, like, to be concave, for h to be concave down, we could also say, oh, h prime is decreasing, but you wouldn't want to reference h prime because we're dealing with the graph of h double prime. Okay, so that's why I keep referring to that. At what x values does h of x have a point of inflection? Explain. Okay, so point of inflection. Very last row of this table. A point of inflection is going to happen either where h prime has an extrema or where h double prime has a sign change. And since we're dealing with the graph of h double prime, we're going to look for a sign change. So points of inflection, here we change from positive to negative for h double prime and then negative to positive. So at what x values, we can't say what the exact points are, but we can say like what their x coordinates are, because we don't have the original function to plug them back into. So at x equals -2 and x equals 4, and then I'll say because h double prime changes from, I'll say positive to negative and negative to positive, and then I'll just say respectively. Okay, so respectively means I had x equals -2 first, and then I said positive to negative first. So respectively means like the one I mentioned first is, this is how it's changing. And then x equals 4, that corresponds to from negative to positive. Okay, or you don't have to use this respectively. You could be like x equals -2 because h double prime changes from positive to negative, and x equals 4 because h double prime changes from negative to positive. Okay, if that's easier for you to say, that's fine. When is h prime of x increasing? Explain. Okay, so now I'm in this column. So h prime, when is it increasing? It's increasing when h double prime is positive, or it's increasing when h is concave up. And we already actually answered this question. I think that was the first question that we answered. But my explanation is going to use this fact because I'm given the graph of h double prime. So when is h prime of x increasing? And then we'll say from -infinity to -2, union 4 to infinity, because h double prime greater than 0 on these intervals. Okay, and feel free to speed up the video, guys. When is it decreasing? It's going to be, so h prime decreasing when h double prime is negative. Okay, so we're kind of repeating some of these answers because h double prime is less than 0 on this interval. Whoops, you can't see. At what x value does h prime of x have a relative maximum? Explain. And then at what value does it have a relative minimum? Okay, so so we're looking for extrema of h prime. Okay, so down here, extrema of h prime. So we're looking for sign changes of h double prime. Okay, so the extrema of h prime are going to occur at these zeros of h double prime. All right, and to have a relative max, you have to be changing from positive to negative, because an increasing slope to a decreasing slope. So positive to negative is happening here. Okay, so I'll say at x equals -2, because h double prime changes from positive to negative. And then where is there a relative minimum? And remember, the extrema of h prime are happening where there's a sign change in h double prime. So the other sign change is happening here, and here we're going from below the x-axis to above, so from negative to positive. So negative to positive, that would give us a minimum. So at x equals 4, because h double prime changes from negative to positive. Okay, and guys, you've probably noticed that these answers are repeating. That's because there's multiple ways of looking at the same things, as you see from Susan's table. Like, all these mean the same thing, all these mean the same thing. The same rows imply each other. Okay, so the homework is page 11, numbers 1 and 2, and I will see you soon. Bye-bye.